Trigonometry, lesson 7.3, trigonometric equations. So again, another relatively short lesson. We're just solving things. Get theta alone and use the information from the previous two lessons to make sense. So plus 1 divided by 2, and I'm being real lazy. If you need to do it in extra steps, of course, go ahead. And where does theta equal? Theta equal 1/2. Theta equals 1/2 at. Where does sine of theta equal 1/2? I had to make sure I couched that properly. Pi over 6 plus 2 pi k, and 5 pi over 6 plus 2 pi k, comma, semicolon. K is all integers. So where does cosine of theta equal 1/2? I believe that's theta equals pi over 3 plus 2 pi k, and all the way down at the bottom, 5 pi over 3 plus 2 pi k. K is all integers. So any concerns? Well, yeah, it's not a function. And I'll put a question mark, like, didn't we care about this? Isn't that why we went through all of that? Yes and no. These get used in graphs, and they'll usually limit the space we can work with. So that's what we do. We say, let's limit it. Now, made a big deal about arcsine and arc cosine and arctangent being functions. Here we don't care so much. Here we say, well, you get more than one solution, that's fine. So go and solve it. 2 sine of theta equals negative root 3. Sine of theta equals negative root 3. Now, I didn't do it above, but a lot of people will do this step. Now we're worried about domain and everything. Worried about, well, I only get one answer. So I don't do that step. I'll leave it written down. I just go right here. Where does sine of theta equal negative root 3 over 2? From 0 to 2 pi, we're looking in the bottom half. And I believe that would be at 4 pi over 3 and 5 pi over 3. That's wrong. No, that's right. Sine of theta, sine. Yeah. So, now let me give you a hard one and give you a new concept. U equals 2 theta. U is what we call U substitution. Something you'll be doing in calculus a little bit over a year from now. So we change this problem to sine of U equals 1/2. Oh, I know where that is. U is at pi over 6 and 5 pi over 6. I don't need all that integer stuff because, now look what I did, because it's between 0 and 2 pi. Oh, and then we just go 2 theta equals pi over 6, 5 pi over 6. And we go up here and say, oh, that means theta would equal pi over 12 and 5 pi over 12. We think we're done. We're not. The 2 over here causes problems. It basically doubles the area we can look. For example, we could have also had said 13 pi over 6 and brain cramp 17 pi over 6. You'd say, whoa, you're outside the allowed spot. So, well, the next step is divided by 2. So these answers would also become 13 pi over 12, 17 pi over 12. And those are our 4 answers. You say, yeah, they're outside the range. No, they're not. 2 pi is 24 pi over 12. They're in the range. So that's the trick. Watch out for it. Is there any way to check these problems quickly? I actually like doing this. Make sure you're in radians again. We just did sine of 2 theta. So let's go sine of 2 theta. And we said it equals 1/2 sine of 2x. And can't help myself like using my little tool here. And what we're looking for is where they intersect. Now it's in radians. So it's giving us, this is, I don't know if you can see my cursor popping up. This is 0, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. I think. Yeah, because it's doubled. So we have 1, 2, 3, 4 answers. Almost 5, but not quite. So you should look for 4. Well, how can I check that I did it right? Let's just pick one. Let's pick the last one. Want the intersection. That's one of the curves. That's the other curve. And now I want to get the give me a hard time. I want to pick the one all the way down on the right. Right about there. And it gives me 4.451. And we had 17 pi over 12, I think. 4.451. Hey, look at that. 4.451. So that's a way to check. A lot of people don't want to do that, but it's not a bad idea. And more problems for you to try. At this point, I would stop the tape, pause the recording, and see if you can do them, because I'm just going to blast through them. We got a problem here. We got cosines and thetas. So I got to change this using the trig identity. And then I got to bring everything over to the same side. 3 cosine of theta plus 3 equals 2, negative 2 cosine squared theta. Bring everything over, 2 cosine squared theta plus 3 cosine of theta plus 1 equals 0. I'm going to do a little guessing and checking here. Cosine of theta plus 1. Actually, it's not really guessing and checking because it's pretty easy. Cosine squared plus 2 plus 1 is 3 cosine theta plus 1. So we have theta. Let's break it this way. Cosine of theta equals 1. Pardon me. Plus 1 equals 0. Cosine of theta equals negative 1. Theta equals pi. That's an answer. And then the other answer was 2 cosine of theta plus 1 equals 0. 2 cosine of theta equals negative 1 divided by 2. Theta equals negative 1/2 at pi over 3, 4 pi over 3. There's 3 answers: pi, pi over 3, and 4 pi over 3. Plug them back in or graph it if you want to see if you got it right. So again, I want to have everything the same, so I'm going to go with 1 minus sine squared theta plus sine of theta equals 2. I'm going to move everything over. I'm not even going to write it out though. 0 equals sine squared theta minus sine of theta plus 1. That doesn't factor. So now I have to see if I screwed up or something. Interesting. Check my notes. See what I did wrong. Alright, I didn't do anything wrong. There's no solution here. Doesn't factor. So A equals 1, B equals -1, C equals 1, theta equals 1 plus or minus square root of 1 minus 4 times 1 times 1 all over 2 times 1. That's insanely confusing. And that is imaginary, because the determinant is negative. So no solutions. The null set. Had me for a second there. So let's use a calculator to get a non-exact answer. And we'll talk about my little comment here. 5 sine of x plus x. 5 sine of x plus x. Goodness gracious. X, and that's going to equal 3. So here we get 3. Graph. So, did I need to limit the 3 places? I didn't write in 0 less than x less than 2 pi sort of thing. Doesn't matter. I only got 3 answers. I could zoom out and show you, but it doesn't hit again. Let's change the window so I can show you. Let's go from 0 to 20, and let's go from -4 is fine to 12. Comes close on that 1 second dip, I guess we should call it. So there's 3 solutions. I would use second intersect to go find them, but in the interest of time, I will tell you, you should get x equals, and unfortunately I have them to 2 decimal places, 0.52, 3.18, 5.71. Wow, that's a lot going on, and that was not a short lesson. I lied. Happy mathing. Trig equations are fun.